Today, lesson 26B, proportional relationships with tables. Before we get into this, our focus lately has been on ratios and rates and unit rates. And we also learned how to solve proportions and word problems where we could use proportions to solve them. Starting today, we're going to spend about 4 or 5 lessons trying to figure out if something is proportional. And we knew how to do that with 2 ratios. If the 2 ratios simplified and they were equivalent to each other, they were proportional. But what if you have some values inside of a table? How do we do that? Well, that's what today's focus is. Tomorrow's focus will be on how do you determine it from a graph. And then the next day it'll be how do you determine it from an equation. So we're going to go more in depth on how to determine if something is proportional, or in other words, if it has a proportional relationship. And today our focus will be on tables, and then we're also going to find something that's called or referred to as the constant of proportionality. So, a little bit of background knowledge. This was something that I just mentioned. A few lessons ago, we learned how to determine whether those 2 ratios were equivalent or not. And if they are, then they are proportional. Well, these 2 are not, and that means that that is not a proportional situation. Whereas here, if we simplified both of them, they both simplify to 6 over 5, that means those 2 are proportional to each other. So we defined this a few lessons ago, that a proportion is an equality between 2 ratios. Well, proportional relationships, and I need to back up for a second because some of you did not write that in your notes. So let me back up. A proportion is an equality between 2 ratios. All right, back to the defining of proportional relationship. Proportional relationships are a collection of pairs of numbers that form equivalent ratios. So we have talked about 2 pairs of numbers and determined, but what if we have more than 2 pairs? And that's what today's focus is. So, example of collections of pairs of numbers that form equivalent ratios. All of these 3 right here, these form a proportional relationship. The reason why they do is because 2/4 is also 1/2. This simplifies to 1/2, and this simplifies to 1/2. Since they all are equivalent or the same fraction or same ratio, that means that is a proportional relationship. So we're just extending it to more pairs of numbers there. Whereas here, and I've kind of already answered that question, if we simplify all these, which they are already simplified, they're not going to be equivalent to each other, so that means that these are not a proportional relationship. So if we have ratios that are equivalent to each other, they form a proportional relationship. And ratios that are not equivalent to each other, they do not form a proportional relationship. All right? So let's go to number 1. Here we have a table of values. And whether you recognize it or not, these are 2 ratios. For 4 hours, you can go 140 miles. For 7 hours, you can go 245 miles. I'm just reading the table. So this table shows 2 trips taken by a family and comparing the miles traveled to the amount of time the trip took. So we're going to define the hours to be represented by the variable x, and we're going to represent miles by the variable y. Now we're going to find out we could use any variables we want to, but for today and tomorrow we're going to stick with x and y. And I know you already have that in your table. But the question is this a proportional relationship or not? Here's the best way to determine it. And you need to make sure that you are writing your ratios correctly. When we write our ratios, and you need to write that word down. Write this down, and then whatever I write directly below it. Okay? We want to write our ratios in the form of y over x. We want our y numbers on top and our x numbers on the bottom. So in my first set of values right here, that's one situation. The family went 140 miles in 4 hours. So let's write that as a ratio. And remember, this is just reiterating what I just said. Always use y over x for your ratios. So 140 over 4, that simplifies to 35 over 1, or 35. Okay? And all I've done is I've taken the first situation from the table and written it as a ratio. Let's take the second situation. I would like you to simplify that and tell me if we end up with the same thing. I'll give you about 30 seconds. Okay, so since 245 over 7 also simplifies to 35, that means those two ratios, 140 over 4 and 240 over 7, they are equivalent to each other. And since they are equivalent, that is a proportional relationship. Can you write that down, please? If within our table we end up with ratios that are all equivalent to each other, that means that results in a proportional relationship. If they're not all the same, if they're not all equivalent to each other, much like in the previous example that I gave you, then that means that it's not a proportional relationship. And that's what we're checking for. Do we have a proportional relationship or not? Okay. So one more time. If all ratios are equivalent, then they form a proportional relationship. And I know in your notes you have a few things that you need to fill in right there. So next we're going to go to number 2. And I'm going to have you check to see if that represents a proportional relationship or not. In number 2, and I'm leaving it right here to make sure everybody gets caught up here. In number 2, you have a table that represents a comparison of meters to seconds. So it says in your notes, this table shows 3 speed trials taken by a person on their bike and comparing the meters traveled to the amount of time that the ride took. So here's what number 2 looks like in your notes. I want you to check right now to see if that is a proportional relationship or not. I'll give you about 1 minute. So if we take a look at number 2, remember we are always comparing y over x, not x over y. We'll see why in a few lessons, why it needs to be y over x. So make sure that your ratios all are of that form. So the first one, 10 over 2, that simplifies to 5. Second one, 35 over 7, simplifies to 5. But the third one, as Jaden told us, that does not simplify to 5. It simplifies to something else. So make sure that you're doing the correct ratios, y over x, and then you're checking to see whether they are equivalent or not. So, since all the ratios are not equivalent, this is not a proportional relationship. Any questions about number 2? Now, sometimes we have tables that are what I refer to as sideways. This table I would refer to as sideways. Okay, it's horizontal. But other times, tables are vertical. Okay, and that's what we see in number 3. In number 3, we're comparing the cups of blue paint to cups of red paint. The cups of red are represented by X. The cups of blue that are represented by Y. Remember, when we're using our ratios, we always check Y over X. So, as you can see, this table shows 3 measurements of a special color of paint and comparing the number of cups of blue paint to red paint. Check right now to see if this is a proportional relationship or not. I'll give you about a minute. All right, so we're checking for ratios y over x. So we have 2 over 3. That's already simplified. 9 over 12. That's 3/4. We can already see that these ratios are not equivalent. We could stop right there. I went ahead and did the third one, but this is not a proportional relationship. All right. Let's now go to number 4. Number 4, we are comparing the number of yards of dirt to hours worked. This table shows 4 measurements of the amount of dirt excavated. Excavated means they're digging it out, compared with the amount of time it took in hours. Check to see if that is a proportional relationship or not, please. All right, so like in all the other problems, we are checking to see if the ratios are equivalent to each other. So we check y over x. 15 over 3 simplifies to 5. 20 over 4 simplifies to 5. 40 over 8 simplifies to 5. And 45 over 9 simplifies to 5. All the ratios are equivalent, so therefore this is a proportional relationship. All right, next we've got some things we need to fill in our notes. If a table has a proportional relationship, the simplified ratios represent the unit rate. You've heard those two words, unit rate, many, many times over the last few weeks. So when I say to you unit rate, you should have some sort of an idea of what I mean by that. But what happens is, and this is why we simplify our ratios, not only to check to see if we have a proportional relationship, but this leads us also to the unit rate. So if a table has a proportional relationship, the simplified ratios represent the unit rate. Next, this is from the first problem we did today. All of the ratios here simplified to what? This is back from number 1. What do they simplify to? Just say it. What? They simplify to 35, right? That means that is the unit rate without the units. Okay? That's the unit rate without the units. So both of those simplified to 35, and as far as the unit rate goes, it's 35 miles per hour. Remember, unit rate always needs to be labeled or it needs to have the units with it. Now, how do I know it's miles per hour? Here's how I know. In our ratio right here, miles is represented by the y numbers. Hours is represented by the x numbers. That's how I know it's miles per hour. That's how I know what the labeling has to be. Okay? Also, here's from number 4. All the ratios simplified to 5, so we know that's the numeric part of the unit rate, but the units would be 5 yards per hour. How do I know yards per hour? Yards per hour. Okay? So we've already really done all the work to find what the unit rate is. Here's something else you need to fill in your notes. When checking for a proportional relationship, the unit rate is typically called the constant of proportionality. When checking for a proportional relationship, the unit rate is typically called the constant of proportionality. Here's an easy way of remembering it. The constant of proportionality is the constant part of the unit rate. In other words, it's the number part without the units. So if our unit rate was 54 miles per hour, the constant of proportionality is 54. It's just the numeric part of that. And if we had another unit rate of a half pizza per person, 1/2 of a pizza per person, what would the constant of proportionality be for that? What would it be? All right, so once again, in 1/2 of a pizza per person, the constant of proportionality is the numeric part, or 1/2. All right, and like many things in mathematics, we use a specific variable to represent it. And usually for the constant of proportionality, we use the letter K. So, one more time, you've got something you need to fill in your notes. K is the variable we usually use for the constant of proportionality. All right. So K is the variable that we use for the constant of proportionality. So now let's go to number 5. Now we're extending it out. We have another problem where we are comparing two things. We're comparing the height of a bamboo in a specific number of days. So this table shows 3 measurements of a specific type of bamboo, comparing the height to the amount of time it took to grow to that height. two questions. I'm going to ask you the same question I asked you in 1 through 4. Do the numbers in the table represent a proportional relationship? And if it is a proportional relationship, I want to know what the constant of proportionality is. And if it's not a proportional relationship, I want to know why. We're just extending basically what we did in 1 through 4. Go ahead and try number 5. All right, so let's check all of our ratios. Y over x. We've got 120 over 2. That simplifies to 60. 180 over 3. That simplifies to 60. 360 over 6. That simplifies to 60. This is one of the main reasons why you need to make sure you are using y over x and not x over y. Because if you don't, you're not going to get the constant of proportionality. Okay? All the ratios are equivalent. That means this is a proportional relationship. That value right there gives us the unit rate, or just the number part of the unit rate is the constant of proportionality, and that would be k equals 60. If I asked you for the unit rate, it would be 60 centimeters per day. We would just need to include the units. Okay? All right, let's go to number 6. Everybody try number 6, please. Same exact idea. Well, remember, to check for a proportional relationship, we checked all of the ratios y over x in the table. We get 1/3 for the first one, 1/3 for the second one, 1/3 for the third one, 1/3 for the fourth one. These ratios are equivalent. Therefore, it is a proportional relationship, and that value that they were all simplified to is the constant of proportionality, so k equals 1/3. All right, one more problem for today. Go ahead and try number 7, all parts. We have 4/3 for the first ratio. It's already simplified. The second one simplifies to 4/3. So far, it's looking like it is proportional, but 13 over 12 will not simplify, and it's not equivalent to the other two. You could stop right there if you wanted to, but this is not a proportional relationship because the ratios are not equivalent. Therefore, there's not a constant of proportionality. All right, we are finished for today.